Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into Docker Compose. Many of you have asked about Docker Compose. So in this video, I am going to explain Docker Compose right from the basics. We will do some practicals in this video and I will also explain you the comparison or the difference between Docker Compose and Kubernetes. So this is going to be a very informative video. Please try to watch it till the end. First thing, let's start with understanding what exactly is Docker. I know many of you have already understanding of Docker. You all know what is Docker. But let me just take a couple of minutes before I talk about Docker Compose. I just want to make sure all of us are on the same page. Docker is a container platform that is developed by Docker Inc. And the main goal of this Docker platform is to manage the life cycle of your containerized applications or manage the life cycle of containers, which is better to say. What does that mean? Using the Docker platform, you can take a virtual machine, install Docker on top of it, or Docker desktop on top of it, Docker CLI. End of the day, using that Docker desktop, Docker CLI, what you can do is you can start your container, you can stop the container. That means you can either delete the container, right? You can run it as a background process. So Docker as a platform manages the life cycle of your container. Assume you are working in an organization. There is a developer and developer is working on a Python Flask application. To make it very simple, let's assume this Flask application is a very simple one. When someone executes this Python Flask application, it runs a calculator, right? So one of your developers is working on a calculator application. Now, the developer has asked you, Abhishek, can you containerize this application? This is a very simple Python Flask application. Can you just containerize it so that I can run it on my machine, other machines? I basically want to run this as a container. So what you will do, first step is you will create a Docker file. You might have to sit with this developer, understand what things have to go into the Docker file, right? You will decide upon a base image. Then using the run, you will install all the dependencies that are required in the Docker image. If you need to expose a port, probably you will expose. And finally, using a command cmd or entry point, you will provide the command that, or you will provide the process that needs to be executed when the container is started. Now the next step, this is the Docker file. Step 2 would be to create the Docker image. To create the Docker image, again, you will log into that virtual machine and probably run the Docker command, that is Docker build, followed by all the parameters that you are interested with. Then the next step would be to run this Docker container, which will be your probably the final stage. And to run this Docker container, which is your Python Flask application, you will use the command maybe Docker run, followed by the parameters. If you want to expose the port to your host system so that you can access this later on the browser, if you have any volumes or any other arguments that you want to pass to the Docker run command. So this is the entire life cycle. And once you run the application, probably after a while, you can also delete the container. You can verify the state of the process using the Docker ps command. All these things you perform using Docker. Now your question should be, okay, if Docker is capable of managing the life cycle of my entire container, why should I go for Docker Compose. If you are new to Docker itself, I'll highly recommend you to watch my Docker playlist where I've explained Docker right from the basics. If any of these concepts that I've explained here went over your head, then please start with the Docker basics. Docker playlist link will be available in the description where you will learn Docker right from the zero. Okay, let's go back to the topic. Now, if Docker is capable of managing the entire life cycle and doing all this, why should someone go with Docker Compose? Docker Compose, on the other hand, is again a tool that is developed by Docker Inc. But here, the difference is that Docker Compose is used to manage multi-container applications. What does that mean? What is a multi-container application? So in the previous example, we were just talking about a simple Python Flask application. And when this Python Flask application is executed, it runs a calculator. But instead, let's say you're working in an organization where your organization is developing a e-commerce application. Now, in the e-commerce application, for obvious reasons, you will not have a single container, or you will not develop it using a single microservice. So e-commerce application will have multiple microservices, will have a lot of databases, messaging queues. It might have caching servers. So let's assume your e-commerce application has 4 microservices, one database, and one caching service. Let's say this is Redis, this is MySQL, and this is a Python application. This is Python login application. This is payments application, and this is transactions application. Now, how will you manage the lifecycle of all of these containers at once? Of course, you can also use the Docker platform here, where for this container, you can individually run the Docker build command. Again, for this, you can run the Docker build, Docker build, Docker build, Docker build, and Docker build. Once this is done, you can individually again run Docker run command on all of these things. Of course, taking dependencies into consideration. Now, what is dependencies? This is a very critical part when you are working with multiple microservices. A basic example can be, here you have a payments application and you have, let's say, a database. Assume payments application should only be installed when the database is up and running. If the database is not running, and for some reason the payments or transactions or catalog which has the images that has to be shown to the user, if the database is not available, there is no point of your catalog application being available. So first thing that has to start is your database, and next that has to start is your catalog. So when you are dealing with multiple microservices, it is not only about running Docker build or containerizing multiple microservices or multiple services, but it is also important that you execute them in the right order. In some cases, you might want to mount a volume, right? Or you might want to mount a data onto an application. So first, probably the configuration application should be available even before your actual application. So the problem with using traditional Docker in this case is, number one, managing the life cycle, taking dependencies into consideration. Number two is running so many Docker build and Docker run commands. Number three, which is also, let's say tomorrow, you share this information with your developers. Right? Initially, You might work on this as a DevOps engineer, where you came up with 10 Docker build commands, 10 Docker run commands. You have taken everything into consideration and you have prepared a shell script, let's assume. So that tomorrow, if you give this information to another DevOps engineer, they don't have to do everything from the scratch. They can simply execute your shell script. After stability of this project, you share this information with a developer, right? Developer want to run and execute these containers for their local testing. Tomorrow, the e-commerce application has a new feature the developer has written. And before even deploying it onto the unit test environment or staging environment, developer want to test it on his or her local machine. That is the laptop of the developer. In such cases, you don't need Kubernetes, right? Obviously, you will run them as containers on your local laptop and you will test it on your laptop because it's a continuous process. Developer might write 5 lines of code that is not working, remove that 5 lines, write 10 more lines. It's a continuous process. So it is better developer gets your script and executes so that all the containers are up and running. Developer can verify his or her future. If it is not working, again, developer will go back, come back and execute your script that you have shared with them. Okay, you have put all this effort, you have shared the shell script within your DevOps team, and you have shared the shell script with the developer as well. After 6 months or after a while, this thing stopped working because there are changes to the Docker commands or there are any changes that has happened during this last 6 months of how the Docker build should be working, how the Docker run should be working. And you know those changes. Now, if you have to give back those things, you have to give it back to your developers, you have to give it back to your other DevOps engineers. This is not a complete declarative approach, right? If instead of shell script, you were using a YAML file or something, right? Instead of running 20 commands, if you just have a single YAML file, and that YAML file is also a standardized YAML file that is provided by the Docker, which provides backward compatibility. That means very rarely it, or it is almost it doesn't break even if there are new changes. So if you have that standard platform, then it is much better. That's where Docker Compose comes into handy. Before I explain any further, let's try to take an example and let me show you so that you can correlate what I am talking about. So we will use this 3-tier architecture demo. We have used this multiple times. This is a fork. I did not write this project. I've taken this from Instana Robot Shop, which is an IBM project. I don't own this project. So I've just taken it. Let's give the credits to them. Now I've used this 3-tier architecture demo on my AWS Zero to Hero, Azure Zero to Hero. It's a very cool application where once this application is executed, it deploys a complete e-commerce application for the robots. So you can buy robots using this e-commerce website. Now, if you look at the complexity of this project, there are almost 12 services. There is a web service, user service, shipping, ratings, payment. Assume your developers are working on this project. And there is a requirement where developer wants to just perform a trial and error. Even developer is not sure if he can fix this issue or not. So he is just trying multiple times. Now, because there are 12 services, every time if the developer has to start all the 12 services using Docker build, Docker run, and again, if something goes wrong, developer deletes all the containers, it's a very tedious process. Instead, if as a DevOps engineer, you write a simple Docker Compose YAML file. Of course, because this is of 12 services, looking at the Compose file, you might feel this is too much. I will take a very simple example after some time. But for now, I want to show you how Docker Compose can help here. So let's take a terminal. I have the same application. I have cloned the GitHub repository. Now, what I will simply do is I will not use the Docker build. I will not use Docker run or anything. I'll just use this command called Docker compose up. And once I run this, it starts all your containers. See, it is trying to create all the 12 services, and it takes some time because it has to take dependencies into consideration. There are two databases. There is a in-memory data store for this project. So first, it has to start the databases. Then it has to start the applications. It has to take care of the bindings, mountings, and dependencies. So let's wait. Okay, I think the project is getting started. Let's try it. So this is how it looks now, right? So what I've done is I used a single command called docker compose up. Now, if I just enter Control C, it is stopping all the containers that it has created. And now if I try to refresh, it's gone. So all that your developer or any member of your team, right? What's the magic here? The most important point here is you just need to know one command if you are not a DevOps engineer, that is Docker compose up. If you are working on a two-tier architecture application and want to test it locally, what is the command? Docker compose up. If you are working on a three-tier architecture application and want to test it locally, the command is Docker compose up. If your application has multiple services, there are multiple databases, dependencies, what is the command that you need to know to start the application on your local machine? Docker compose up. That's the beauty of Docker compose. So DevOps engineers does all the heavy lifting, that is writing the Docker compose file, writing the Docker files. You still have to write a Docker file. I'm not saying you don't have to write the Docker file. I will come there in a minute. But the advantage is when you are dealing with such huge projects, even you have the Docker file, starting the application takes a lot of steps. That can be avoided using Docker compose. Once you are done, you can also run this command called Docker compose down, which will just remove the containers, or if there are any stale containers, it will get rid of it. Typically, when you press the Control C, the containers are stopped, but it might run. If you search with Docker ps -a, there might be stale containers or they are not completely removed. So just run Docker compose down and all the containers that are created are removed. So the biggest advantage is the developers, QA engineers, they just need to know this command called Docker compose up. And once they are done, they will just run Docker compose down. Now, how does Docker compose work? Right? Abhishek, you have explained about Docker compose, but how does it actually work? Most of the times, Docker compose comes with your Docker installation. Let's say you're using Docker desktop. If you're on Windows or if you're on Mac, I'll highly recommend using Docker desktop because Docker team is working very actively on Docker desktop. There are continuous upgrades to the Docker desktop. It is becoming more and more stable. So I would recommend using Docker desktop. And if you use Docker desktop, you get the Docker compose out of the box. Let's say you're on Linux and you're not using Docker compose. It's very simple. Just go to the documentation. One of the best documentations that I've seen from Docker or any application is Docker compose. Docker compose documentation is very straightforward. It explains everything in detail. For now, let's go to the install page. Just click on the overview. Are you on Linux, Mac, or Windows? Let's say you're on Linux, that is, you are trying this entire thing on your laptop with Linux flavor or on an EC2 instance, virtual machine, wherever you are trying. The commands are also provided. Let's say you're on Ubuntu, just run these commands and you get your Docker desktop up and running. Very straightforward. My bad. Docker Compose up and running. Very straightforward. Now, once you have the Docker Compose, what is the next step? Right? I have my Docker Compose up and running. The next thing is understand that Docker Compose is not a replacement to Docker. Docker Compose, if you are trying to containerize your applications, you still need to write the Docker files. You still have to write the Docker Compose YAML file. And what this Docker Compose YAML file does is it will explain or it will understand how to build and run your containers. Just the same thing, right? When you have multiple services for your application, you just need to write one compose file, which is a YAML file. And what this YAML file does is it will build and run your containers. But for building, it still will reference your Docker file. Or if you already have a Docker image, then it can also reference a Docker image. But most probably you want to build things from the scratch. So for the build, Docker Compose will still be looking at your Docker file. For running and execution, yeah, it will just run Docker commands internally. You don't have to bother about it. Now let's see how to write a Docker Compose for a very simple application, right? Now the application that I'm going to see is a Python application, or let's take a Node.js application. Yeah, let's take a Node.js application. So what we will be doing now is we will take a Node.js application because we do a lot of things with Python. A lot of times people ask about Node.js. So we will take a Node.js application which runs as two replicas, or there are two instances of your Node.js application. There is Nginx, which is serving as a load balancer. And using the load balancer mechanism, Nginx will forward the request to node instance 1, node instance 2 randomly. And there is also a Redis. And what this Redis does is it keeps the information. Typically, we are using it for the caching. So Redis will cache the information on the number of requests this load balancer is getting and how many times is it forwarding the requests, right? So this is going to be a simple application. There is a user front facing is Nginx, which is a web server. We are also using it as a load balancer. From Nginx, the request is routed to the node instances. There are two copies of the node instances, and we have Redis for caching the information, right? So I will show you again what exactly is this application. Then we will learn how to build it, how to write the compose file. So the repository that I'm going to use is Awesome Compose. So Awesome Compose is basically set of Docker Compose examples that are written and uploaded. This is maintained by the Docker team itself. That is the beauty. There are so many Compose examples. If you try to spend some time and look at these Compose examples, there is every possible thing that you can do. Do you want to run a Golang Nginx application? Here is the example. Do you want to run a Python Flask application with Nginx and MySQL? You have an example. Do you want to run Flask with MongoDB and Nginx? You have an example. You take anything, you will mostly try to find the compose examples in this repository. So I will be looking for Node.js. So this is the one that I was talking about, Nginx, Node.js, and Redis. So I have cloned this repository. It is available on my local. I'll just search for Nginx, Node.js, Redis, and let me run Docker Compose up. I just want to show you what is the application. Then probably you will understand in a much better way how and why I'm writing this compose file. What are the steps that I'm following? This will not take much time. It's a very simple application. So it is first creating the networking. It is starting the Redis here. And once the Redis is started, it is trying to start the Node.js. Web1 is the first container instance for your backend application. Web2 is the second container instance for your backend application. Usually it shouldn't take much time, but for some reason it is taking longer time here. Let's wait. Okay, meanwhile, let's see if it is running. I'm running it on localhost 80. Okay, it's still running. It is taking time. In your case, it might not take so much time. Okay, it took some time, but finally it is running. If you want to understand why did it take time, basically while experimenting, I have added a restart policy, and that restart policy is not working for this particular containerized application. So I've used a wrong restart policy. Because of that, it was taking a lot of time. I just removed it. But otherwise, okay, now if I just try to start the application localhost colon 80. See, this is how the application works. It says request went to instance or copy one of the Python Flask Node.js application. My bad. Number of visits is one. Next time when I hit, number of visits will become two. How is it remembering? Because we used Redis, right? So the information is cached in Redis. I'll show you the code as well. So the information caching server is Redis, which is keeping track of the number of requests that it is getting, the entire website is getting. And Nginx is load balancing between Web 1 and Web 2. So next hit, this might become Web 2 or might not become Web 2, but number of visits will be 2. Let's try. Perfect. Web 2 number of visits is 2. Web 1 number of visits is 3. Right? It is basically now see, it said Web 1 number of visits is 9, Web 2 10. So it is taking the traditional load balancing, the round robin load balancing mechanism. That's why once it is Web 2, next time it is Web 1, then it is Web 2, then it is Web 1. And Redis is tracking the information of the number of requests. That's why it is getting incremented. The great thing here is that even the request goes to Web 1 or Web 2, Redis is tracking the information, caching it, because it is connected to both the copies of the instances. Okay, now how do I write the compose file for it? Before writing the compose file, you should focus and understand about the project little more, right? Do not step forward and start writing the compose file. Sometimes you might find it very easy, so you just jump onto it and start writing. But firstly, spend some time, probably take 2 hours, 3 hours, even one day, sit with your developer and try to understand what exactly is this project doing. You don't need to understand the code. You don't need to understand the syntaxes, but just try to understand the architecture of the project. Here, there is web and there is Nginx. If you go to the web, which is the Node.js application, what is it trying to do? Just go to the server.js. Like I've explained, it is talking to Redis client. So first, it will install Redis. Then it connects to Redis on 6379, right? The port 6379. And then you have a very simple logic where it is looking at the get request on the context root slash. When someone hits this application, when it receives the request, then it counts the number of visits and cache that information in Redis, right? Redis client dot set. It is trying to set the number of visits. And this application is started on port 5000. Now, this is the same one, whether you create 1 copy, 2 copies, 10 copies, the web server, the Node.js code will remain the same. So what we will do is we will install this first. We will run it on port 81. Then we will install it one more time and run it on port 82, right? Only thing that we will try to change is once we will call it as web 1, once we will call it as web 2, right? This application, first copy, we will call it as web 1 and we will run it on port 81. Second time, we will install it as web 2 and run it on port 82. What is port 81 and 82? I'm talking about mapping the container port to your host system, right? So I'm simply talking about within the container, application is running on port 5000, but this is running on a virtual machine, right? In my case, it is running on my laptop, but in your case, it can be running on a virtual machine or any instance. When we install the first copy of Nginx, I will map the container port with 81 port on this virtual machine. Second time, I will run the same container, call it as web2 and map the port 5000 with 82. So the Nginx, which is also installed on the VM, once sends the request to port 81, second time it sends the request to 82. And this happens in the round robin algorithm. Redis will also be installed here, as I have explained. So if you go back to the code, okay, this is about the web code. Then you have the Nginx code. In Nginx, you don't have any programming. There is just a nginx.conf file. This file is for your web server configuration, where it understands how should it perform the load balancing mechanism and what are the servers. Server 1 is web 1, server 2 is web 2. And it listens on 80, right? The load balancer is listening on port 80. That's why I accessed it on localhost. Perfect. Let's go back. Now let's try to understand how to write the Docker Compose file. If anyone is asking you to write simple Docker commands for this, very straightforward, right? You will initially start with the Docker files for it, which are already available in this folder. The Docker file for Nginx will look something like this. From Nginx 1.21.6, you will use a run command, basically trying to remove any existing Nginx configuration in the Nginx Docker image, and then copy our Nginx config file onto the same location, that is the default config location. Because when you install the base Nginx image, it comes with a default Nginx configuration file. We are just removing it and we are adding our Nginx configuration file. Then if you go to the web, which is the Node.js application, again, the Docker file is very, very simple. We will use a Node.js base image, decide upon a work directory. It can be anything. It can be /app. It can be /tmp also. Copy the package.json, which is typically the requirements, application dependencies of your Node.js application. You will copy it onto a location. Then run npm CI, copy the source code of your Node.js application and just run npm start when the container is started. So these are the Docker files. Now, without Compose, you will simply say Docker build. Let's say you will pass any arguments and you will provide the Docker file location. So first one will be inside the web So you might say web followed by the Docker file. Then next you will say Docker build. What is the second directory? Second directory was Nginx, and you will provide the Docker file location. So both your Docker images are built. And then to start the web, because we want to create two copies, you will probably say Docker run. I want to run it as a background process. So probably I'll pass -d. Then I'll say -p, where I will map the 5000 port with port 81. Then I will provide the image name. Let's call it as web1. Second one, I'll almost follow the same thing and say Docker run -d -p 5082 web1, sorry, web2. I'm just roughly writing these commands. Please do not take them as accurate ones. Then to start Nginx, again, I will use the command Docker run, whatever is the Nginx related command. So this is how we will run. Now let's convert them into a compose file. So compose is a YAML file. So the syntax, if you know YAML, you already know the syntax of Docker compose file. Using the version of compose file, just like we do in Kubernetes, is optional. But what is the mandatory? Mandatory is a service keyword. You don't need to remember this exactly. You just need to know the concept of Docker compose, and you just need to know what are the fields that goes into the Docker compose YAML file. So you will provide services. Within the services, what are the names of your services? First one I can call as web1. Next I can call as web2. Next I can call as Nginx. Within this, that is within the web1, what do you want to do? I want to build it. How do you build? Provide the location of your Docker file, right? Same, web2, how do you want to build? Provide the location of your Docker file. Nginx, same thing, right? Do you want to add any deployment related properties? You can just provide a field called deploy, and within that you can provide, like, do you want to have the restart policy as always, or do you want to have the restart policy as on failure, which are typically the Docker parameters. This is how you write the Docker compose file. Let's see if I am correct or not. If you go to this one, there is a compose file already. Please note, you can also clone this repository, fork it, try the examples. They are publicly available in the GitHub repository of Docker organization. So services keyword, web1, as I've explained, you will just say you will just say build. What is the location of your Docker file? Host name, sorry, I forgot that. You will provide the host name as web1. Then you will use the ports. I'm mapping 81 to 5000. Then you will use web2. Again, you will map the port 82 to 5000. Rest all is the same. Nginx, and you provide the port mapping 80 to 80. Depends on. This is the most important thing. Abhishek, you said using the Docker file, you can manage the dependencies. You can define which container has to be built first, which has to be built next. How does that work? It depends on this parameter called depends on. So for Nginx, there is this parameter called depends on, which says Docker compose that create this particular container first, then create this one. Only after that, you can install and create the Nginx service. Because there is no point of having Nginx up and running. Let's say Docker image build and Docker image run fails for web1. What is the point of having Nginx? Nginx might succeed, but there is no point of running Nginx without having web1 or web2. Just like you have your application failing, but your database running, what is the point? Without the application, you cannot talk to the database, right? So what you can do is probably first start your application or vice versa, depending upon your requirement. right? So Docker Compose file is not at all a rocket science. It's a very simple thing. All that you need to know is first start with the services keyword and what you want to build. These names are uh, they are not any standard. You can call it as Abhi, you can call it as anything, right? So what depends is what are you writing inside this. So my service name is web1, other service name is web2. So within that, first thing, the mandatory thing is you have to provide the build. Within the build, you have to provide the location of your Docker file. So for web1, this is my Docker file. For web2, again, the Docker file will be the same. If you don't want port mapping, then you don't need this. But in my case, I want to map the container port to my host port. So that's why the same 5000 for web1, I map to 81. Same 5000 for web2, I map to 82. So that this load balancer, which is running on port 80, can once forward the request to 81, second time can forward the request to 82. Then we have the Redis. In case of Redis, like I've explained you, for Compose, Docker file is not mandatory. It can also take a Docker image. We are not building the Redis container. We are just using the Redis image that is publicly available. So we have provided the Redis image location and the port. So this is how you use the Docker Compose. If you want to learn what are the different fields, this is the most standard way. Like even if you look at the 3-tier architecture e-commerce application, if you go to the Compose file, more or less, you will find the same keys. Services, here, the first service they're talking about is MongoDB. So there is build. You are providing the location of it, right? For Redis, again, we are not building Redis from scratch. So we will be just using the Redis image. And then there is networking. This particular application is using Docker networking. So there are different networks. One is the robot shop network. So we are creating the robot shop network. So we are providing the networking configuration in the Compose file as well. All the parameters are the same one that you pass to the Docker command. So within the Docker command, you say Docker build or Docker run -p. -p is nothing but the ports, right? If you go back to the example, in Compose file, ports is similar to -p and network here is similar to -- network that you pass. If you want any logging for this application, we have also set up the logging for each container. That's why we have the logging field as well. So if you want to learn more about Docker Compose, what are the different arguments that goes into the Docker Compose, best thing is just go to the documentation. The documentation of Docker Compose is super good, like I've explained. Docker Compose docs. It will hardly take 1 or 2 days to go through each and every file that is available here, but each and everything is explained with an example. You have more than 30 to 40 examples in this particular repository that you can try out. Whether your organization is using Python, Node.js, Java, you have all the examples for those applications. You can learn them and you can implement Docker Compose within your organization. Finally, when is Docker Compose used? Now, this is the last question that you might have. Okay, Abhishek, you have explained this entire thing. When is Docker Compose used? And how is it different from Kubernetes? So one of the most popular use case of Docker Compose is, like I've explained, local development. So as a DevOps engineer, if you write the Docker Compose file and share it with your developers, their local development will become very fast because they don't have to focus on running the applications. They don't have to think about all the commands that are required to run the applications. All that they do is Docker Compose up, Docker Compose down. So local development is one of the most common use case. even if your application is running on Kubernetes, to test it locally, you can test them as containers and you can use Docker Compose. Because end of the day, even in Kubernetes, containers are running as pods. You have services, ingress, but the lowest level within the pod is a container. So developers don't usually test everything on Kubernetes. They have Docker installed on their machine. They either run them as Docker container to quickly test it, or they use Docker Compose if there are multiple applications. Okay, one is local development. Second popular use case is CI/CD. Let's say you don't want to set up a Kubernetes cluster. You have a CI/CD that is running on every pull request. You don't have capacity to run those many Kubernetes clusters. And every time, whenever a pull request is created, you don't want to spin up a Kubernetes cluster and you just want to test on a virtual machine, right? Because Kubernetes is expensive or setting up and configuring it becomes very tedious. Probably in your organization, you have, I'm talking about local CI/CD. I'm not talking about dev environment, staging environment, or production environment. A CI/CD that runs on every pull request. This is not related to any environment. Even in this case, what you can do is for the pull request CI/CD, you can set up a virtual machine, and within the virtual machine, you can install Docker. And in your CI/CD pipeline, you can just run Docker Compose up, run a couple of tests to verify if the code changes that are implemented using the pull request are valid or not. Then the most other common use case. We talked about local development. We talked about CI/CD. Other use case can also be with respective testing. So if you want to perform a quick testing, it can be any environment. You just want to verify, let's say there is a QE team, and QE team, even before installing, deploying through the CI/CD or manually on their local machine or the staging environment, if they just want to quickly verify what developer is saying, developer said, I have implemented the changes. If QE want to quickly verify, they can also use Docker Compose. These are the most common use cases, at least that I have come across with Docker Compose, and I've seen organizations doing it. Next thing is Docker Compose versus Kubernetes. So the equivalent to Kubernetes in the Docker ecosystem is actually Docker Swarm. So the discussion about, Docker Swarm. So the discussion about Docker Swarm versus Kubernetes is not that logical, because Kubernetes is basically an orchestration platform where you have a cluster that is configured using multiple nodes, multiple virtual machines. And this orchestrator is a very powerful thing where it has a mechanism for auto healing. It has a mechanism for advanced load balancing using the CRDs. It has the capabilities for implementing multiple replicas across multiple nodes of your Kubernetes cluster, auto scaling, scaling them down, performance, a lot of things when it comes to Kubernetes. So the comparison should also be, the comparison should be Kubernetes versus Docker Swarm, but it should not be Docker Compose versus Kubernetes, because they serve complete different purposes. Compose can be used to run multiple containers, manage the lifecycle of multiple containers, but this is not exactly a orchestration platform as Docker Swarm. So if you are in the Docker ecosystem, Kubernetes equivalent is Docker Swarm. Docker Compose is used for these things. I hope you found the video informative. Please try out the examples. You can try out the 3-tier architecture demo. Try to run it using Docker Compose. There are so many examples available in this github.com github.com/docker/awesome-compose. This is the organization and this is the repository. There are more than 30-40 examples. You can try out them. You can learn how to write the compose files, and more things are also available in the documentation. Thank you so much for watching today's video. Please let me know your feedback in the comment section and see you all in the next one. Take care. Bye-bye.